Alright, so now we're going to just do some practice questions. So let's refer back to the special rules we derived. So perfect square trinomial when there's a minus, and the difference of squares case. So now we can do this very quickly if we remember the rules. So there's a perfect square trinomial. So we can take the first term in the binomial, you square it, then 2 times x times the second term plus the second term square. So simplify this to x squared plus 4x plus 4. So again, this is just to save you time, but if you're hardcore and you want to do it from scratch, you still get the same answer. So don't get discouraged. It just takes more time. But once you recognize the rule, you can apply it. So it'll be much faster to answer all of these questions. So you see the second one, there's a minus sign for the perfect square trinomial. So it'll be the first term square minus 2 x times okay, I kind of messed it up. I should explain it a little bit differently. It's going to be 2 times the first term times the second term plus the second term all square. So x squared, 2 times negative 3 will be negative 6x. Negative 3 squared is positive 9. Okay, that's much better. Okay, now we have a difference of squares. The scenario that sets up a difference of squares, right? The a plus b, a minus b scenario. So then we apply our difference of squares formula, which is the first term square minus the second term square. 1 square is just 1. Okay, let's keep going. Oh, this is another difference of squares scenario. So this will be the first term square minus the second term square. So 4x squared minus 25. Another difference of squares case, right? X minus 1 times x plus 1. We have a difference of squares. So it's just the first term square minus the second one square. So it's just going to be x squared minus 1. Whoops, I realized I made a mistake earlier. It's the exact same thing, just rewritten differently. Oh, okay, so now we have to do the rule for more challenging cases. No, I'm joking. It's not challenging, still easy. It's the first term square plus 2 times the first term times the second term plus the second term all square. So now we just have to simplify this to 4x squared minus 4x plus 1. Keep going. Now they're trying to trick us. They're putting a negative outside, but we're going to take care of the negative after all of this. First, we're going to take care of the x minus 3 times x plus 3, which is a difference of squares. So let's open up brackets. The first term square minus the second term square, which would be 3 squared would be 9, so x squared minus 9. Now we have to take care of the negative part, so don't forget to multiply it in negative x squared plus 9. Not so tricky after all. Okay. Or another case they're trying to trick us. They're putting the negative outside. So let's just keep it outside for now. And let's take care of the bracket term. Y minus 1 squared. So what's our strategy for trinomials? So the first term square minus, well, it's going to be plus 2 times the first term times the second term plus the second term all square simplify this. Negative 2y plus 1. Then we deal with the negative one, so we can expand this out. Negative y squared plus 2y minus 1. Awesome. Math is easy. So easy. Great. We could do this all day, right? All day, every day. All right, questions. Are you going to get more tricky now? No, you're not. 3x plus 4 times 3x minus 4. We recognize this as the setup for difference of squares. So is the first term square minus the second term square. So 9x squared minus 16. Oh, not even a challenge. Okay. J. Oh, same thing. How many times do we need to practice this? Well, let's do it an infinite number of times. The first term square plus 2 times the first term times the second term plus the second term all square. What does that simplify to? 4x squared minus 4x plus 1. Fantastic.